thing, just to add on to the thing about the torque, he was saying sometimes the homework, there is a right answer for positive, negative. That's because the problem or the picture itself tells you what's positive, what's negative. So that in that case, the positive and negative matters, right? If I said this is positive, okay, right hand rule, okay, this would be a positive torque, this would be a negative torque, and this would be a positive torque, or whatever. It's a two-dimensional picture. It's hard to tell which way they're actually turning. Okay, but if they don't have the axis, whatever you declare as positive, negative is positive, negative. Okie doke. All right, let's try to solve it real quick, so we can get to the good stuff. Bending and moment. Okay, whoever didn't write their name on the last quiz, you're the guy that drew the surfer dude that said cowabunga. So, on your moment diagram. That's literally the idea. Moment diagram. Wait. And he put a little caption that said cowabunga. I was like, okay. Alright. Free body diagrams. Reaction. You gotta put names. You can't just draw it. You're gonna have to put a name. So moment A, moment B, moment C, and then moment, let's call it reaction. Okay, you got 7, 5, 18.
I will try to sort it by like.
Okay, sum of moments equals 0.
Sweet. I meant just to Gmail, but it's like this slide.
Okay, let's say this way is positive. So these two are positive, and this middle one's negative. So 17 plus 18 is 25. That's convenient. Minus 5 is 20. But since you're bringing it to the other side of the equation, it's minus 25. Or minus 20. Kilonewton meters. Units. Okay, that's pretty easy. All right. Now you got to go through and see how much torque is in each piece. Okay, this first piece, you would have the 7, and then the reaction. Okay. Yeah.
It should be positive because shouldn't it be minus MR since it's going in the same direction as MD?
Yeah. Okay, I drew it negative.
Yeah.
So it should be minus and minus.
So it would be minus MR, yeah. If I had drawn it the other way, it would have been negative. But just know it's in the same direction as this one. That's what it really matters. Okay, yes, you're right. But when you draw your free body diagram, you can draw this any direction you want. Right? So just remember which way it goes. Okay? You might have to put like clockwise or counterclockwise. Alright. So for A to B, you got the 7 kilonewton meters, and then you have the reaction, equal and opposite. So you know the torque going through this is 7. Okay? I'm not going to write out each equation. You should on the exam, but I'm not going to, because, yeah. Okay? The next one is 7 minus 5, so it's 2. Okay? These are in the same direction because the 7 is greater than 5 in the other direction. Okay, the next piece is plus 18, so 20. And then that should be correct because at the wall you're going to hit another 20, and that'd be your 0. Alright, for tau max, tau for this one equals 7, remember it's kilonewton meters, times the C value, which would be half of that, 50 millimeters, and then put it in meters, so it's 0.05 meters over pi over 2. 0.05 to the 4th. Okay, the next one would be 2 times half of 10 is 5, and that's 5 millimeters. 2 times 0.05 4th. And then the last piece would be 20 millimeters. 50 is 25. Right? Yep. 2. Oh, 25. Okay, you can solve the 3, and then you pick the biggest one, because that's what the question asks. How max? Okay? I'm not going to go over every possible example, but they might ask you, you know, what's the max torque you can apply without exceeding this many pascals for shear stress. Okay? You would have to work backwards, solve the equation in a different way, so just be cautious of that. For the angle of twist, like I said, you know at the wall is 0. So you start from the left, twist. Oh, you actually start at B, right? Yeah, twist the B. So twist the B equals twist of link BC plus CD. And because you know D is a wall, that's where you stop. Okay? Equations. Torque of B, torque of this, let's do this. I'm just going to write the equation over here, TL over JG, okay? Torque of this portion, 2 times the length, 0.1, over the same J value, times the G, 60 times 10 to the 9th. Okay? Remember, giga is 10 to the 9th, mega is 10 to the 6th, kilo is 10 to the 3rd. Okay? That should be all you need to know. Okay? Plus 20 times length, 0.3, 5 over 2, 4, 60 times 10 to the 9th. Okay? Remember, it's in radians. We'll probably take the answer in both. We will take the answer in both radians and degrees. Yeah. And that should be it. Any other questions? Any problems with this? Okay, remember, I can't cover every example. I'm not going to go over a gear problem. I'm not going to go over a hollow, but I gave you all the questions to solve from. Just remember, kind of follow those 4 steps. Free body diagram, write what you know, find the solving condition, plug and chug. Should be good. All right?
Ready?
Okay. I don't know what the official subscripts for this, but this is what it is. Okay. When you have, when you're rotating about this axis, okay, rotating from here is different from rotating from here. Okay? It's like holding a dumbbell right here and then holding a dumbbell out here. This is a lot harder, okay, because it's so far away from your body. They're different. I said IC because it's right on the center, on the neutral axis, and I put F for floating. I don't know if that's right. It's probably, not the official thing. Okay? I do not know if she will give you how to calculate moment of inertia. So I would make sure I know at least the rectangle and the circle. Okay, remember, this is different from this, right? I believe this one is 112? Yes? 112? 112 dh cubed or whatever, and then this is 1/2. Oh no,
112.
1/3 dh cubed. Okay? Remember to get your bases and heights right. Okay, the base is going to be along the axis, parallel to the axis, and the height is going to be perpendicular. Okay? You might want to draw this. If you just flip to the back of your book, it'll tell you all the I values. Make sure you know the circle ones too. When using this equation, okay, this IC is as if the piece was right on the center of the neutral axis. So you would use this equation, not this one, to find this IF. Okay, so make sure you don't use the wrong one. Okay, area, and then D is the distance from the center of the floating piece. So don't miss that. Okay, so the question is, what is this axis? This axis is the y bar, right? Pretty sure. Pretty sure. Yes, that would make the most sense. This is the y bar. Big y bar. Okay. So if you visualize it, okay, the moment of inertia depends on where you're rotating your mass about. Okay? When you're finding the y bar, you're realizing, okay, because of its geometry, the center of the bending, or where it's bending about, is not in the middle. So that's the D you have to use to find the correct distance. And then a lot of times, when it comes with this question, they'll ask you for finding the max compression and the max tension. Okay? So let's say for this problem, for example, is bending this way. Top is in tension, bottom is in compression. Okay? Normal force or normal stress is equal to what? My bar. No, let's not call it y bar. Let's call it MC over I, right? Okay. I told you how to get the I. You got your moment. It's going to be positive because it's in tension. Let's say this is the top. Top. Okay. The C value is, okay, remember, I said the C value for a solid cylindrical shaft is going to be the furthest from the center. That was because it was rotating about the center. It was bending about the center. It was twisting about the center. Here, it's not twisting about the center anymore. It's twisting about the Y, or bending about the Y. So this C value is going to be the distance from the most upper part of the piece to wherever your Y bar is. Okay, it's going to be that distance. Does that make sense? Not confusing anybody? Okay, that's that C value. So remember, make a note of when you use the outside C, if you have to subtract by the Y bar, etc. Okay, for the bottom, it's going to be the same thing. So let's go C top, C bottom. Okay, because the bottom is going to be a compression, I'm going to throw in a negative sign. The C bottom is the distance from the bottom of the piece to the Y bar. Okay. Remember, since I threw in this negative sign because I knew it was compression, don't throw in another negative sign because of the C value, because technically the C, the distance from this bottom part to the middle, would be a negative number. Okay, so don't throw in two negatives and then you'll get a positive, and that's going to be wrong. Okay, so be careful with your positives and your negatives. Any questions on this stuff?
So what you're just saying, so the C is just the Y bar, then it's the Y bar?
Yeah.
Okay.
So for the bottom, since we found Y bar relative to the bottom,
Yeah.
the value of C is Y bar.
Okay.
If we had done it from the top, it would be the distance from the bottom minus the Y bar. Right? Any other questions? Alright, next thing. Alright, who's still writing on this? Who's still writing this? I'll move it down. symmetrical bending, or what I like to call multi-dimensional bending. That's how I like to word it. Okay, it's like if you were to have this kind of piece, and you have your moment bending, bending this way. Okay, the easiest way to do this, in my opinion, is just break it up into two components. All right, so let's say x, y, and let's say this angle is 30. Okay, from the x, 30 from the x. Okay, so the x moment is equal to m cosine 30, and the y moment is m cosine 30. Okay, so now what have you done here is split it up into two pieces that look like this. Okay, if you're ever wondering which way is twisting, just follow the convention, right? Right hand rule. Everybody know the right hand rule, right? You point your thumb in the direction of the arrow, and then the direction your fingers curl is the direction the moment's applied. Okay. So this is pretty straightforward. The only thing I'm going to cover is, once again, the positives and the negatives. Okay. So say they say find the stress there. Okay. You're going to have stress due to the mx, and you're going to have stress due to the my. So I'm going to just leave it at this equals mx c value over I x, my c value over I y. Just close that. Okay? mx and my are going to be different. Okay? cx and cy are going to be different for the most part, because cx is the distance from here to the x-axis, and then cy is from here to the y-axis. Okay? Ix is going to be in this direction, so let's say the center just happens to be here. The biggest issue with this Ix and Iy is both going to be some form of I to the third bh cubed plus I to the third bh cubed, right? Because say the axis happens to be here, which it probably isn't. You have this rectangle, right? You're rotating, the outside of the rectangle is touching the axis. So you're going to have some form of this, okay? But remember, the base is always, what, parallel to the axis, and the height's always perpendicular. So when you have the Ix, you're trying to find it along the x-axis, right? This will be your base, and then this will be your base. And then the other two dimensions will be the heights. When you're calculating about the y-axis, these ones are going to be your base, and then the other ones are going to be your heights. Okay? That's why it's important to distinguish between Ix and Iy. They're going to be different. Okay. Now going back to positives and negatives. All right. I do that bad. Whatever. Okay. There's a second right-hand rule. It's actually my favorite right-hand rule. It kind of looks like a gang sign. I said this way was positive x, and I said this way was positive y. So the question is positive z in or out of the board? Raise your hand if you think it's in the board. Raise your hand if you think it's out of the board. It's in the board, okay? X-axis is your thumb, y-axis is your index finger, and then your z-axis is your middle finger, okay? This is the Newton's Law gang sign or whatever. I think at a physics club in high school, we were the Newton's third law, and this was our gang sign. So every time we took a picture, we'd throw this out. We'd be like, what the hell? All right. So let's say into the board is negative for this question. Or positive. Into the board is positive. Into is positive. Okay, I'm not going to make you know the that thing. I don't. I think that's out of the board and that's in the board, but I'm not letting you know that. Okay, just remember, into the board is positive. Okay, so the moment, the stress due to the moment x. Okay, right hand rule, thumbs pointing the arrow. On top is going into the board, on the bottom is coming out of the board, so that would be negative. Okay, y direction. To the right's into the board, to the left is out of the board, so they're both negative. Any questions on how I did that? Okay. It was kind of confusing because a couple homeworks ago, one of them was wrong because they got the sign in the book wrong. So make sure you follow the right-hand rule. These kind of problems, they'll give you an index. They'll tell you which way is positive y and which way is negative y. Just remember your right-hand rule this one, and then your right-hand rule this one. So you should be good with the positives and negatives. Any questions? Angle of neutral axis. Okay, remember, for this kind of shape, we knew it wasn't going to be in the middle. We knew that. But since it was bending this way on the board, you knew it was going to be horizontal. But if it's at an angle, that's not necessarily true. So, let's see. Oh, this is Z and Y. So let's say, what was Z and Y in that problem? I think this would be X. I am not sure. It does matter. It does matter if which one's on the top. I'm trying to remember your homework problem. It was something like angled like this, right? You guys remember this one? And then the moment came out this way. This was y bar and this was z bar. And then in that equation they used z prime over y prime. So just following that, I'm going to put x over y. I would go back and make sure you know which one is going to be on top and which one's going to be on the bottom. Because it does matter. We'll change your numbers. Tangent, theta. And then this theta is this 30 degrees. Theta. Okay? So you solve for phi and this is your neutral axis angle.
They use IC.
Yeah, I know, but I wrote X and Y, so I wasn't sure which one was which.
Yeah, the IX should be on top.
Yep. So this would be correct. Woo! That memory. I remember some weird things in your homeworks. Like, you know, the funny stuff, like the surfer dude, when people do one problem out of the 6 and they get, 20 points and they're like, he's a hard grader. Dude, come on. What am I supposed to do? What else do I remember? Somebody wrote Happy Halloween on the quiz, like I was going to give him a better grade for writing that. I mean, it was nice. All right. Okay. Oh, one thing. I sent an email out. If you know the neutral axis is like this, right? And you have the choice between this point, and this point. Okay? And they ask you to find which point has the maximum stress. Okay? There are a couple ways to do this. One, you solve the stress for all 3 of them, and then you pick the maximum one. 2, you draw a very, very clear picture showing that this point is furthest from the axis. Okay, whichever point is furthest from the axis has the most stress. Just like, you know, all the C's I've been telling you. If you're finding tau max or sigma max, the C is going to be furthest away from the axis. Right? Same thing here. You could say it's the furthest away from the axis, but you have to make it clear. And you got to either draw it or you got to write something. You can't just say, you can't just put sigma d equals and then that happens to be the right answer, but I don't know if you know why or if you just guessed and you got 1 out of 3 shot. Okay, so make sure you make it clear. If you make any assumptions, just write it down. Okay, doesn't hurt. We good? All right.
Not good.
All right, let's do a. What time is it? Okay, we got plenty. Let's do a practice question. Okay. When it comes down to these questions, the hardest part is finding Y bar and I. Okay. Moment's pretty easy to find. Finding the C is pretty easy to find. It's going to be the Y bar and the I. So I'm going to draw a picture, and we're going to try to calculate the Y bar and the I.
What's that alpha?
That is the angle of the neutral axis.
Okay.
You guys want a fun one or a boring one?
Probably boring.
All right, let's do 2 of them. Okay, something you probably see on the test. Okay, let's say these will all be in. I don't care what units. This is 10. This is 2. This is 3. The length of this is 6. The thickness of this is 3.5, and the length of this is, well, that's 10. That's got to be like 21.3 or something, right? Yeah, there's your boring one, right? All right. So you're looking for I and capital Y bar. The fun one. I don't even know if I want to solve the fun one, but I thought it'd be cool to draw. Is this hollow? Boom, baby. Oh, I got the right numbers for this. Oh, this is going to suck. Let's say each of these are 2. This is 4. What have I done to myself? 3. The radius of this is 2. The thickness on all the sides is 0.5. Yeah, I'm not going to solve this. No way. And then the length of the body is. Sure. Okay. I didn't cover how to deal with hollow stuff. I totally forgot. I'll cover the hollow stuff right now. Okay? You got a simple shape like this. Alright. It's I total equals I outer minus I inner. If it's symmetrical, and the neutral axis in the middle, it's pretty easy. It's going to be. Let's pick some numbers here. 5, 2, 6, 3. Okay. My outer is going to be times height. Okay. Also remember, when you are solving for Y bar, the areas are negative for the hollow parts. Okay? So that'll be your I total. And then Y bar, remember it's some of the areas Y bar. you're gonna get something, you're gonna get, let's see, 30 times 0. Wait, no, y bar is in the middle, what am I doing? But you know what I'm saying, right? If it's got mass, it's a positive number. If it doesn't have mass, it's 0. I mean negative. If it's a whole, it's negative. Okay? So that's how you deal with whole stuff. You had this one homework question that was like this. That was pretty hard. You won't get that on the exam. I don't think. Maybe. Who knows? It's confidential. But remember, you can go back and see how you solve this. It's actually a pretty long process, which I won't cover without the video. Okay, so let's at least do this one. I'll give you a couple minutes. Find the I bar, a y bar, and the I for this. If you want to take the fun one home and try it, go ahead, bring it back to me, and I won't tell you if it's right or wrong. I don't know. We're going to find it from the bottom. Start from the bottom. Who said that?
What?
Did you guys notice earlier when I wrote one of the dimensions, I put 1738? Yeah, dude. I trapped out. Alright. I'm just kidding. Don't invite me to your parties. I'm not going to go. Let's do y bar first. Some of the junk. Okay, this is how I cut it. Boom, boom. Okay. From the bottom. We're going to find y bar from the bottom. So this would be, let's do the top piece first. 21.3 times 3 times the y bar of that would be 2 plus 6 plus half of 3 would be what? 9.5? Okay, plus next one, 6, 3.5, and 2 plus half of 6 is 5. This 2 times 10 plus half of 2 is what? All over the areas, some of the areas. 21.3 times 3 plus 6 times. Does anybody actually get a number for this? Did anybody get a number?
Yeah.
What?
6.978.
6.978. Maybe she'll give you ugly numbers, maybe she won't. I don't know. Alright, so there's your y bar. So that should be what? That should be like here. Okay, moment of inertia. I total equals, it's called the top piece 1, the middle piece 2, and the bottom piece 3. I1 plus I2 plus I3. Okay? And then because none of these are exactly at the centroid, you're going to have that situation for each and every one of them. Yep. So you're going to get 1/2 base 1, height 1 cubed plus, I'm just going to write it like this. Squared, dot, 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 dot. Okay. The distance, so for piece 1, the center is going to be here, which is, what did I say it was? 9.5. And since y bar is at 4, this d value is going to be 9.5 minus 4. Okie doke, any questions? Also, if you get the d value down here, your i's are never negative. Okay? It doesn't make sense to have a negative number. So this d value, I'm pretty sure is absolute value, even though it's below the y bar. Okay? I can't be negative. It's like having negative mass. What does that mean? What's black matter, dark matter, whatever it's called. All right. Add them all together, and you'll get your I. You're not too lazy. And we need to move on. Yeah?
Shouldn't it be 9.5 minus 6.978? Where'd you get 4?
Where did I get 4?
Yeah, that's the question.
Yeah, what he said. See, this is why I make them 6.978. You're right, you're right. Any other questions? Good?
Oh, 9.5.
All right. Remember, the I and the Y bar is probably going to be the hardest part, and I think she's interested in giving you a cross section that is going to be weird. It's not going to be a perfect square with a perfect hollow square in the middle. Okay, it's going to be something weird, so make sure you practice this kind of stuff. All right, I'm going to bring this down. Anybody need the bottom board? All right, let's do it. On to chapter 5, the harder bending question. All right. Like I said about the quiz, most of you didn't even get to the shear and bending moment diagrams because you couldn't even draw the free body diagram correctly. Okay? You gotta draw the free body diagram correctly. And she told me she gave you some she told you to go from the side that doesn't have the wall and solve for it, and then it sounds like you guys got confused. So this is what happened on the quiz, okay? You would do this, you have this force. Okay? This is how a lot of you drew your free body diagrams. You had this force, which most people got, and this force, you had this, and then you had this. Who's doing that? You know, it's not, the dragon isn't doing that, some imaginary figures are doing that, okay? You guys seem to be getting confused when we chop it up into segments, so let me distinguish the two, okay? The free body diagram is of the whole system. That's the one we care about. The proper free body diagram for this one is this. Okay, and that is the proper free diagram. This is what we're looking for. This is what's going to get you 10 out of your 25 points for that problem or whatever. Okay? And then what you guys start to do is you start to break it up. Okay? You go from here to here. Okay? You have this, and then you have reaction forces and moments. Okay? This is how you're supposed to do it step by step. Okay? And then for the next part, you would have where these are the same, right? And then you would have another set of reaction forces. And then it keeps going. Okay? Do not confuse this with the correct free body diagram. Okay? Yes, there's moments on both sides of this because it's in the middle. It's like this is in the middle of the piece. There's going to be, when you cut the piece, there's moments on both sides from forces on both sides. But when you're drawing the entire free body diagram, if there's nothing over here, don't draw a moment because that's wrong. Yeah?
For the moment on the wall, how do you know which direction it goes?
You can close your eyes and say which one makes sense, or you could just do the math, right? So, okay, let's call this, what was it? O, A, B. And let's say I choose this way. Okay, right hand rule. Let's say this way is positive, this moment is positive, these ones cause a negative one. Okay? Sum of the moment at sum of the moment at O equals 0 equals, I'm gonna call this M reaction. Okay, I said it was positive. Minus A times the first distance minus, okay, remember, distributed loads, you need to write an equivalent load and then find the distance of that. So for a rectangular distributed load, okay, let's say W, and the distance is D. The value of the equivalent load is in the middle of this because it's rectangular, symmetrical, W times D. Okay, so the units for this will be something like 4 newtons per meter, and this will be a value like 1 meter. So the equivalent load would be 4 newtons at half a meter from where this started, in the middle. Okay, if it's like, I doubt she'll do something like this. If she has, a triangle, okay, the equivalent load is going to be the area under this triangle, and it's going to be a little off center. That's exactly center. I don't know. It's going to be a little off center. This should be in the back of the book, but then again, I doubt this is what she'd give you. Okay, so you definitely need to know the consistent distributed load one. Okay, so your moment, MR, and then B equivalent, which is the W times D times the distance. Remember, so this distance would be right here. Okay, it's not the very end. A couple people use the distance at the very end. That's not correct. That's not the equivalent load. It's putting it in the middle. So let's call that, D2. Okay, that's how you. Okay, and then I drew a positive. I bring these values to the other side. Everything's positive, so that means it's going in the right direction. Okay. If I drew it the other way, right? This would be a negative. I would solve it, and then my M value would be negative. So what does that tell me? That's telling me it's going in the opposite direction that I drew it in. Okay. So your negative and positive signs will be dependent on how you draw it. Good. So free body diagram. You guys gotta get that down. You guys did okay finding the value for this? Okay, but let's go over the shear and bending diagrams for this problem. Okay? Shear. I'm going to tell you, remember what Dr. Sapaska said, and it's because we talked about it and we figured there'd be a lot of confusion. Okay? We're not worried about which way is positive and negative. Okay? This is the things we're worried about. The signs have got to be, or the shape has got to be relatively correct. The direction, your V and your M diagrams have to be the same. And you need to put significant values. Okay, so what are significant values? Any points, right? When it turns, you need to tell us what that point is. When it's flat, you need to tell us what that value is. When it's 0, you don't have to tell us it's 0. You know it's 0. But you need to put those points. If you just draw it, that's not enough, because you could have just and drawn it. Alright? So let's look at this. Okay? I'm gonna just make up numbers. Okay? Let's say this up value is 10, this down value is 6, and then this value over here, the W equals, let's use these numbers. It's 4 over a meter. Okay, so that means 4 times 1 is 4, 4 plus 6 equals 10. Okay, so it should work out. Alright, so let's draw it. Okay, I just like to think if the arrow's up, it's positive. That's the easiest way for me. So at this very first point, you have an up arrow of 10. So you immediately go up and you're at 10. Okay? Are there any other forces in between here and here? No. So that means your shear value is going to stay at 10. 10 the whole way. Okay? Then you get to here. This is 6. So you go down 6, negative 6. Okay? 10 minus 6 is not negative 4. You got a lot of that. 10 minus 6 isn't 16 either. I don't know. So a lot of people got, well, not a lot of people, some people got that mistake. So this comes down to 4. Okay? Just because it's pointing down doesn't mean after that it has to be negative. Okay? It can still be positive, it's just less. Okay? And then the last thing, another thing a lot of people messed up on. Okay? We calculated an equivalent force to find the moment. But when they drew this, they used this force instead of this one. Okay? This is the actual picture. This is the actual picture, so you have to draw for that. Okay? When you have a distributed load, it's at an angle. The shear force is at an angle. It's increasingly decreasing, if that makes sense. Okay? At a rate of negative 4 per meter, and that should come to 0. Are there any questions? All right. All right, the next thing. I don't want to make up numbers, but the MR in conventional coordinates is positive, right? It's going this way, okay? But how I like to do it is, if this is positive, that means the slope's going up, okay? So, since these are going this way, I'm going to make that positive, and I'm going to make this negative. Okay? I'm talking about moments, okay? These cause a positive moment, this causes a negative moment. I'm just doing that for my diagram, okay? So in the quiz problem, you should have started down here at what, negative 655, okay? And then you have this slope of 10, okay? It's going up at 10, whatever it is, okay? And then the slope changes immediately to 4, okay? The smaller the value of your slope, the flatter it is, okay? Remember that. If you remember that, it makes it a lot easier to draw it, right? We're not making sure your angles are perfect or anything. Okay, so it should be flatter at 4. Okay? And then here, it continuously gets flatter, 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 okay? If your V value is a diagonal line, your M value should be a parabola. Okay? So it should be something like kind of. Close enough. Okay? So what points would you need to put? Okay? There's 10 and 4. That would get you your points. Okay? Here, you would need the starting point, negative 655. This was negative 135. And this was negative 45. Okay? So, to find the values for this, you just balance out the forces. Okay? You add and subtract forces as you go. Okay? And to find the values for this, okay, when you have a moment at like any spot, okay, that's a straight up and down line, a certain amount. Okay, this is your M graph will cut up and down. Okay, when you have force like that, a singular force, okay, that changes this value, so they'll come at an angle, and then I'm just drawing this. Okay. To find the distance between these points is the area under the respective shapes up here. So what a lot of people will do is they'll draw their free body diagram. This is probably the way I would do it. You draw the free body diagram like this. Okay, and then you line it all up. That's lined up. Okay. I should have thought of this better. But you line it all up, okay? Right? If you line it all up and you just look at the free body diagram, you're like, okay, the shear's got to be 10 all the way up until it hits this arrow. That's when I'll drop it down to 4, and then it decays. And the same thing here. It would be the same slope up until you hit that force, and then it would change again here. So how do you find these values? Okay, it's the area. So the difference from here to here is the area of this rectangle. Okay, so it would be let's say this distance, whatever number this is. This distance times the value of d in the quiz. It would be 10d equals, what is that? 520. 520. Okay, that would be the area of the rectangle, and that's how much you know it goes up. Okay, so the next part, under this rectangle, it'd be 4 times that distance, and that would get you 90. Okay, and then remember, a lot of people mess this up too. Area of a triangle is 1/2 base times height. It's not just the base times height. The rectangles are base times height. The triangle is not. Okay, so that would only be 45. A lot of people put 90 on the quiz. Okay.
How did you get negative 655?
That was just an answer on the quiz.
How do you get that value though?
This value right here. Find the initial moment at the wall. Okay. All right. The best way to get used to these problems is just to practice, in my opinion. So we'll do a practice one. Gosh, there's so much to cover. What time is it?
7.
I don't know if I'll finish. All right, we're going to cover the equations. I'm pretty sure you'll be asked this because if we don't, it's not enough points to give out. All right? Just draw one for now. Okay, V value. Okay, let's say the slope of this is x, the slope of this is minus 2x, the slope of this is 3x, and the slope of this is minus 0.5x. Okay, and then the distances, let's just call this A1, A2, wait. Sorry. A1, A2, A3, A4. Okay. So this is how you approach it. Okay, you start from left to right. The equation for the first line, the slope x. Okay, V equals the slope times the distance. Oh, no. Oh, these are bad numbers. All right, let me change these. These x's aren't x's. Because this is the x-axis, okay? I'm going to make these numbers w. So you got positive w, minus 2w, 3w, and then negative half w. Okay, don't use x. That's a bad number. Or variable. The x-axis is the x, okay? So for the first part, this line is going to be the slope times the distance. But because you're going from 0, A1, you keep it as x. Okay, you keep it as x. Okay, this is simple. You know, have you guys ever seen y equals mx plus b? That's what I'm doing. But the b is at 0 because the way I drew it starts at 0. Okay. You got the slope w, and then you keep it at x because it's still a function. Okay? Alright, so let's go on to the next part. A1, A2.
So are these just all distributed loads?
Yeah, that's what it would be, yeah.
This is no reaction load.
Yeah, they all cancel out perfectly. I made this problem up, dude. I just made it up. They all cancel out perfectly. Just assume that. Okay? So, now you're drawing this line. Okay? How do you approach this line? Okay? You start from this point, and you're going down. That's what it is, okay? So your shear value, what's the slope? The slope is negative 2w. Okay? Now this becomes the new x. This A2 becomes the new x value. Okay? Now where did you start from? You started from here. What is this value? This value is w times A1. Oh wait, I messed this up, huh? Times A1. Hold on. This isn't right. It's x minus A1. Okay? Why is it x minus A1? Because the portion with this slope is only from here to here. Okay? So if your x value was this point right here, A1 plus A2, you would subtract the A1, and that's how much you would actually be traveling, is A2. It's kind of confusing. There's a lot of variables in adding and subtracting. Okay? So when you work this out, you get x plus 2WA1 plus WA1. Okay? Now you get this equation. Okay? This is where, just one of them. Okay? What you're doing is, when you're writing the shear equation, you're writing the equation of the line. So if you were to extend this line, the value would be up here. Okay? Remember, y equals mx plus b, where y is the y-intercept. Okay? That value is 3 times w times a1. The same right there. Okay? Are there any questions? Okay, so you would just continue the same thing for the next step, okay? From A2 to A3. Your V would be equal to, okay, what's your slope? It's 3W. Okay? You're doing the X values. X values. Not including A2 and A1, because this slope is only applied to A3. And then the starting point, what value is this? If you plug in A2 for X, you'll get some value, and then whatever this value is, you'll plug into here. So it'd be, let's take this and going, -2W A2 plus A1. Because it's the total distance, right? It's the total distance from A1 to A2. That's X. It's not just A2. Is this right? See if that makes sense.
Are you subtracting A1 and A2? Oh,
Where?
never mind. They add.
Yes, yeah, the X is here. Because I'm only going from 2 to 3, so you, in this X right here, you plug in all of this.
What's the middle term?
What?
What's the middle term?
Middle term?
Yeah.
Where?
That one. No.
Plus
No. The other way. There you go. That one.
2W?
That's in parentheses.
A2 plus A1.
A2
Because I'm plugging in A2 plus A1 for this X right here. Good? All right. As for moments, remember, moment is equal to the derivative. So what? D V over dt. So if you just take the derivatives of these equations, it should be good. Dx, yeah. All right, any questions? All right, we're gonna do an example problem, and then I'll open it to whatever you guys want. We're not gonna go over chapter 6 at all. I'll let Dr. Srinivasa go up to that. Example problem for this, and then you guys can ask any question or ask me to do.
Wait.
Let's do. You know for sure this is going to be on the exam. For sure. 10 out of 10. This is 3 newtons per meter. This is 5 newtons. This is 6 newtons. 10 newtons, okay? This distance right here is 2 meters. This distance right here is 1 meter. This distance right here shear and bending, make sure you find the reactions. Draw a good free body diagram. I'm going to draw one too, so make sure it compares. And I won't make you write the equations, but I'll write them out for you guys. Diagram. You know there's a reaction force. Once again, you can draw it either way. Just make sure you know your positives and negatives. Okay? I'm gonna say this way is positive, and I'm gonna say this way is positive. This is what people usually draw with their stuff. Okay? I'm gonna draw it over this way. Call it MR. Okay. All right, let's find the R value first. Sum of the forces in the y direction equals 0 equals Ry minus the equivalent of this is 3 times 2, so 6. 3 times 2. Okay, this is positive here, so it's at 5 minus 6 minus 10. Ry equals 6 plus 5 plus 6 plus 10. I just brought it to the other side. 12, 22, 17. Ry is equal to 17 newtons. Correct? Alright, moment equals 0 equals, okay, I drew my MR positive direction, so positive. The equivalent is at the middle, so the equivalent is going to be 6 newtons down at 1 meter, okay? And it's going in the negative direction because that's how I drew. So 6 times 1 plus 5 times 3. Yeah, don't mess this up. It's not 5 times 1, it's 5 times 2 plus 1. So 3. The next two are in negative direction. 6. 10 times 11. Right? MR equals 6 minus 15 plus 36 plus 110 equals minus 9, 27, 137. This is in newtons times meters. Alright, let's draw it up. Alright. I'm going to just line it up with this. Okay, shear. Remember, there's a reaction shear at the very beginning. I'm going from left to right. I'm American, so I read left to right. What's the value of Ry? 17. So we're going to start here, 17. Okay? It immediately goes into a distributed load. Okay, so you're going to have a negative slope because it's pointing down. And it's at 3 newtons per meter. Okay? By the end of it, I get through all the load, and the equivalent load is 6. So I should end up whatever 17 minus 6 is. Okay? I should be at 11. Okay? And then it goes flat for a little bit. There's no force there for a little bit. So for that 1 meter, there's nothing. Flat. Okay? Then there's an upward force of 5. 1 plus 5. Shoots it up to 16. There's no force in between that force and the next one. So you come here. Downward force of 6. Drop down. Okay? No forces in between, so it's flat. This value is 10. To 16 minus 6 is 10. And then 10 minus 10 should get you 0. Good? Good. M. Okay. I'm I'm going to do the same thing. If the shear is positive, I'm going to draw a positive slope, so that means the initial moment is going to be negative. That's just how I draw it. Alright? So, we're going to start at negative 137. Okay? All the numbers I'm writing are the numbers I expect you guys to write. You have a distributed load. Okay? It's going to be the area under this, whatever this is. What is it? Trapezoid? Triangle plus rectangle, whatever that is. Okay? So you got to do the math for the triangle plus rectangle. This is over 2 meters. So this rectangle is 11 times 2. That's 22. Okay? And this part right here is going to be 6 times 2, 12. Half of that is 6. So 6 plus 22 is 28. Right? So you go up 28. Oh, it's a parabola because this is not a straight line. It gets flatter as you go. Whatever. Okay? What did I say? 28? So negative 109?
16?
Something like that? Okay. Next part. It's a flatter slope. 11. And it's 1, so it's 11 more. So let's just say is like this. 11 more will get you at, what's 109 minus 11? 98?
Shouldn't it start positive?
Yeah, you could do positive, but since, if you were to start positive, these slopes would be negative, and you would draw downward. You could do either or. It's just preference. As long as you get the shape and the values right. Shape and values. 98, okay? Then you hit the 16. 16 is steeper than this 11, so draw it a little steeper, and it goes for 3 meters. Let's just say, this isn't going to work out too well for me, huh? Yeah, it's not going to. All right. So 16 times 3, what is that? 48? So 48 more, right? Yeah, 48 more. Should end up at 50. Okay. 10 for the last 5 meters should get you to 0. Okay. So what matters is these points, values. You should if you can't tell, make a note that this is a parabola. We'll probably count points for that. Everything else is a straight line, so you don't have to say anything. You should. As for shear values or the equations, from here to here, okay. Shear equals. Okay, your slope is 3 or negative 3. Negative 3 times the distance plus the initial point, which is plus 17. Okay? The shear from here is 11. Shear here is equals 16. Equals 10. Okay? And these equations, similar matter. You can draw them out if you want. Any questions? About anything? Alright, last 20 minutes or so. If you have any questions or want me to do more example problems, let me know. Otherwise, that's all I'm going to cover. I'm going to tell Dr. Zupanska to cover Chapter 6. God bless. I hope you guys get Chapter 6.